Example 6, fully factorize this expression. Right, 2x cubed plus x squared minus 18x minus 9. I'm looking for something I can pull out to start with, but there's no common factor of each of those terms. So I'm just going to have to get on and factorize it, I think. Now, I know that it's going to factorize into 3 brackets. And I'm wondering how I can ascertain what one of the brackets is. What I'm going to do is I'm thinking that perhaps I'm going to have a 3 here, maybe a 3, maybe a 1, maybe have a minus 3, maybe a minus 1. There are lots of possibilities there, aren't there? Obviously, a couple of these are going to be x's, and one of them is going to be a 2x. So it's going to be something like that. What I'm going to do is I'm going to use the factor theorem to see if I can ascertain what one of these 3 brackets will be. Because if, for example, f of 1 is 0, if that were the case, then x minus 1 would be a factor, wouldn't it? So I'm going to explore f of 1, f of minus 1, see how I get on. Okay, so let's have a look at f of 1. The value of f of 1, well, that would be 2 plus 1 minus 18 minus 9. That does not equal 0. So x minus 1 is not a factor. Okay, let's try f of minus 1. Well, that would be, substituting into this expression here, that would be minus 2 plus 1 plus 18 minus 9. That does not equal 0. Okay, let's try f of 3. Well, 3 cubed is 27. 2 27s are 54. 54 plus 9 minus 18 threes. 18 times 3, 18, 36, 54. So that's minus 54 minus 9. Look at that. F of 3 is 0, which implies that x minus 3 is a factor. So I'm winning. So now I know that 2, change colour, make it a bit simpler, 2x cubed plus x squared minus 18x minus 9 is x minus 3 multiplied by something. How can I find that something? Well, I could do a division, but I'm going to do it by inspection. So let's do this by inspection. So x would need to be multiplied by 2x squared to get my 2x cubed. But if I did that, then I'd have minus 6x squared here. And I need plus one of them. So I'm going to need to have another plus 7x squared. So if I write plus 7x here, then I'm going to get that plus 7x squared from there. But if I write plus 7x there, then I'm going to have minus 21x. And I want minus 18x. So I'm going to need to write plus 3 here, so I get an extra plus 3x from there. But if I write the plus 3 there, then I'm going to end up with minus 9 here, but that's okay, because I've got minus 9 at the end. So I have now split my polynomial into 2 factors. The question is, can I factorize this any further? I bet I can. Let's have a look. So I'm going to have x minus 3. Right. Clearly, this is going to be a 2x and an x, and I'm going to have a plus and a plus. Now, I need numbers that multiply to 3. So it's going to be 1 and 3, and 3 are 1, isn't it? If I try the 3 and the 1 first, and that's going to give me 3x and 2x. That only gives me 5x's, not 7x's. So that didn't work. So let me try the 1 here and the 3 here. Let's have a look at that. That gives me 1x and 6x, which gives me the 7x. Good. So I believe now that we have factorized that polynomial fully, and the factorized version is x minus 3, lots of 2x minus 1, lots of x plus 3. Good. Let's look at part B. Hence, i.e. use your previous answer, sketch the graph of the polynomial. Right. So let's start by drawing a set of axes, not in fluorescent. There we go. Right. So I know that when x is 0, my polynomial has a value of -9. So I know it's going to go through -9 here. Great. I know the roots of my equation are 3 from the x minus 3, minus a half, and minus 3. Okay, so let's have a look. Well, my polynomial with high values of x is going to have very high values of y. So it's going to start up here. So it must be doing this. No, I don't think much of that, because that -9 is unlikely to be the minimum, I think. So I'll try again. It's going to go something like this, and then like that. Not a good drawing, and then like that. There you go. Not a great sketch of the graph, but I've shown the y-intercepts and the x-intercepts, so that'll do for now.